Welcome back to Maths with Mrs. J. I'm wanting to start a series of videos about surds. And before I start actually talking about how to work with surds, I want to start thinking about how surds are placed in the whole big picture. Let's just think about the real number system. The real number system consists of any number that can be marked on a real number line. Okay, here's our real number line. So any number that we could mark there. By the way, is infinity a real number? Well, no, because if we were to put it as far up as we could, there'd still be somewhere further up we could put it. Infinity and negative infinity are actually concepts rather than numbers themselves. Anyway, back to the beginning. Obviously, when people started using numbers, they started using counting numbers, natural numbers, so like 1, 2, 3, etc. Because the need was to count things. How many of this thing do I have? About 3 BC, the concept of zero was introduced. Now, the set of whole numbers consists of all of our natural numbers plus 0. This is set notation here, these curly brackets, and the members of the set are divided by commas, and obviously they go on forever with these particular cases here. Now, at some point in time, positive numbers were no longer sufficient. So we had 1, 2, 3, etc. But then we started thinking about things like debt. We might owe someone something. So this brings in integers. Now, integers obviously are all your whole numbers plus your negative versions thereof. And I will do a series of videos on how to work with integers as well. Q is the set of rational numbers. Let's just write these next to them. So this is the natural numbers, whole numbers, integers, rational numbers. Now, rational numbers are numbers that can be written in the form A over B, where A and B are members of the set of integers, all right? So, in other words, they can be written as what we would normally refer to as a fraction. Now, what numbers are rational? Well, obviously, all of these are rational because you could write them as that over 1. All fractions are rational because they're already written in the form of a fraction. What about decimals? Let's just think about this for a minute. Decimals. Well, if it's terminating, so say it's 0.12, even if it had 100 decimal places, you can still put that as a fraction over a power of 10. So this, for example, is 12 over 100, and we can simplify it, but that's enough to say that, yes, that is rational. Every recurring decimal will also be a rational number, and I will show you how to change from a recurring decimal into a fraction in our next video, just for interest. However, any decimals that are non-terminating and non-recurring will be irrational. This is a set of irrational numbers. Now, your set of irrational numbers are quite interesting. Irrational numbers are generally divided into what we refer to as transcendental numbers, which are very special irrational numbers. Now, you've already met one of them. You would have met pi, maybe in late primary school, maybe early secondary school. Pi is used obviously with circles, circumference, area, that sort of thing. It's also used a whole heap in trigonometry, all right? The unit circle, all of those sorts of things. There's another very important transcendental number, and that's E. And that has a whole heap of ramifications later down the track with differentiation and all that sort of thing. Pi is approximately 3.14 and E is approximately 2.71. But the only way to write these numbers exactly is to write them with those symbols. Any decimal or fractional version of them will only ever be an approximation. The only way to write them exactly is as is. Then you have your surds. Now, if you take the square root of 16, you get 4. That's not a surd. That's in fact a rational number. In fact, it's an integer. In fact, it's even a natural number. But if you try to take the square root of something that's not a perfect square, so say something like square root 17, then that is a surd. What will happen is if you do that on your calculator obviously only has a certain number of decimal places it can round off to, but in theory it would keep going on forever and ever and ever. It would be non-terminating and non-recurring. And the only way you can write a surd exactly is to write it like that. It could also be something like the cubic root of something that's not a perfect cube. So something like cube root of 20. All right, so surds is going to be our big topic that we're about to deal with, but I wanted you to sort of understand how it fit into the whole situation. Now, surds can go on the number line exactly. I'll just show you how. I get a line here. If I measure this line from 0 to 1, right, and now I'm going to pick that line up and I'm going to move it. Okay. Okay, now if I get another line in a different colour and I measure from here to here, right, if that's 1 and that's 1, this will be root 2, won't it? Now, it's not exact, it's not the best thing ever, but if we now take this line and move it down to here, rotate it, where that ends up on our x-axis here will be root 2. Now, as I said, that's not perfect. You can actually do it very well with a compass to measure and then draw your little line, but that would be where root 2 roughly would be. So surds can definitely go on a real number line. They are real numbers, but they're not rational numbers. Okay? So real numbers consist of all of these. What's C? Well, C is the set of complex numbers. So they're the things that cannot go on a real number line. We've talked about trying to take the square root of something that's not a perfect square. What if you tried to take the square root of something that's negative? Well, we know that in the real number system we can't do that. However, in the complex number system we can. I do have a series of videos about complex numbers if you're interested in that. Okay, next video I'm going to show you how to change recurring decimals into fractions.